Oh, this is going.
Hello, students of Seneca.
Hey, everybody, how you doing? Happy Friday.
Happy Friday. You got 2 days off exams.
Oh my God, I know. And today was brutal. It was math and English and bio, I think today.
It's a lot.
Brutal. Sort your life out, AQA. Oh. So, thanks everyone for joining. I'm really excited for this live stream. What are we going to be doing today, Rich?
So we're going to be talking about a bit of circle theorems as requested on Instagram. We're going to be talking a bit about simultaneous equations as well. What else we do? I can't remember.
There's a triangle question.
Triangle questions. We're going to look at 2 types of circle theorems.
It's a lot.
Because there's 2 slightly different questions that we're going to look at. And we're also going to look at some algebraic formula.
Yes,
so we're going to be looking at some quite tricky topics. They're all based around exam questions that you might see in your exam next week, which is perfect for what you need to do. And the advice we give to you over the weekend is just get practicing with loads of exam papers. Use the predicted papers on Seneca if you're a premium user, or you can go and see the old papers on whatever exam board you're using. You're doing in your school,
exactly.
Right?
And make sure you look at those mark schemes, because that's what the examiner is going to be using to mark your papers, and they're a really good learning resource. So make the most of those. And as ever, thanks for getting all your requests in. It makes it easier to plan these videos. We're trying to be structured, but also fun. So should we dive in? Should we get going?
Get going. Let's get going.
We'll keep an eye on the chat for any questions, but we'll try and stay on topic. But It's Friday. Let's have fun. Let's
go, Johnny.
I love it.
Friday.
Have we shared the screen?
No, we haven't. We should probably do that before we start talking about it.
And then let's dive in. Also, for anyone watching this after speed us up ×2 speed, it's going to be great. And the specs are fairly similar for maths. So if you're not on Edexcel, this will still be useful. Circle theorems, they come up everywhere. If you're doing A-level maths, you'll come across them again. Okay,
so let's start actually with a ratio question before we look at
that was the other one.
Yes, that was the other one that we can remember.
So ratio question to begin with.
So Dolan enjoys baking and sells meat and fruit pies in the bakery in his cafe.
Grim. I hate meat.
I think that's separately meat and fruit, not meat and fruit together.
Okay.
That would be odd.
That would be grim.
On one day, Dolan baked 1,000 pies. He's a busy guy.
Jesus.
The ratio of meat pies to fruit pies was 7:3.
Okay.
The bakery sold 1/4 of the meat pies in their shop.
Okay.
And the cafe sold 115 meat pies in the other shop.
Okay, so what's the question?
Or 2 in other shops, sorry. So, were more than half of the meat pies that were baked sold? You should show how you arrive at your answer. And that's key for every single one of your questions. Always show how you get to your answer.
We love working out. We show you're working out. We love it.
So there's a few different things you need to do here. First of all, you need to work out how many meat pies there actually were. All right? And you can do that using the ratio in the first bullet point.
Yeah.
And then you need to work out how many were sold in total. So that's using how many were sold, first of all, in their own shop, and how many were sold to another shop. All right? I'm holding 3 fingers up, not 2.
3.
I know you could only see 2. Sorry. So let's have a look at how we do that actually using the math. So calculate the number of meat pies baked. So we have 1,000 pies in total.
That's a lot of pies.
And we're going to split it into the ratio 7:3. That's meat pies to fruit pies.
Yeah.
All right. So 7 + 3 is 10 in total. So you can think of it as there are 10 parts in total that we're going to split these 1,000 pies up into. Okay, 7 of those parts are going to be meat pies. 3 of those parts are going to be fruit pies, but we need to know how much is in each part.
Dude, I want to know. The tension is killing me.
So the way we do that is we do 1,000. We divide it by those 10 parts.
Okay.
And then we times it by the 7 because we want 7 of those parts to work out how many meat pies we got. Right?
Okay, that makes sense.
That's going to give you 700.
Okay.
So then we need to calculate the number of meat pies sold in the bakery. Now, if you go back to the question, the bakery sold 1/4 of the meat pies in their shop.
Okay.
Okay. So 1/4 of 700 is what we're going to look to do. And you can do that by 700 divided by 4.
Okay, nice.
Which is not an easy calculation to do, but you can do it in your...
oh, that was so good.
Thanks, John.
Your mental math is...
you can do it on your calculator if you're not sure, because you've got a calculator exam tomorrow. All right?
Yeah.
So the answer was 175.
Nice, okay.
So Then we calculate the total number of meat pies sold. So we know we got 175 sold in their shop, and they sold 115 to the other shop, right? So 175 plus 115 is 290.
Awesome.
Okay. So this compare the total number of meat pies sold. So 290 meat pies were sold in total. They need to sell how many? 350 to sell half of them overall. Because do you remember in the first part we worked out there were 700 meat pies. So overall the cafe sold less than half of the meat pies baked.
Good. Right. What a fun way to structure a question. Look at that. It looks beautiful.
What I'd say is really good. So you've done all the maths, which is great, but that last statement's really important as well. All right. So make sure the examiner's completely clear in your mind how you got to the answer. If you want gongs, let's get those answers coming in. I've seen a few people who are coming up with good answers. So that's great.
That's the 290. Thanks, Tiger's Eye. Great job. So I am so excited. I love circle theorems. I think I said that in the last one. So I'm glad this was a requested topic.
I think you're the only one, Jono.
I don't know why. I just like circles. I like the circle song on YouTube. Look it up after it. It's bomb. So I'm going to take the next question, which is a circle theorem question. Now, this is, I say now a lot. It's just what I'm learning. So let's read the question. So the circle has a center O, and the points A, C, and D all lie along its circumference. Now, when a point lies along the circumference, it means the distance from O to that point on the circumference will be a radius. Good thing to remember. Nice keyword. We love a radius. So, and it even tells us they don't always, but OA and OC are radii of the circle. The lines A, B, and BC are tangents that have been drawn to the circle. Oh, love tangents.
Love it
so much. So O to A equals O to C, which is 10 centimeters, and O to B is 15 centimeters. And if it's not labeled on the diagram, if this was the paper, I would write 15 centimeters on O to B to make sure I don't forget. So always annotate the diagram with the information that's in the question.
And they may not also, so here the question's got a dotted line from O to B. They may not have that in the exam.
Right? Yes. So always annotate it so you don't forget anything. And now it's a 5 marker, so it's a corker. This is like an essay question of a math paper, math question. And we need to give our answer to 2 decimal places. There's always a mark for that. So even if you're not sure and you're guessing the answer, give it to 2 decimal places because you can get a mark just for the right amount of decimal places. And we want to find the area of the blue region. So what are we going to do? First of all, I'm going to talk over the circle theorems we need to remember for this question. So when we have a point and we draw a tangent to a circle, and a tangent just touches the circumference, the tangent forms an angle of 90 degrees.
It does, right angle.
A right angle triangle. So we know that triangle O to A to B is going to be a right angle triangle. That's right, aha. So that's going to help us with the answer. We're just like, what am I doing here? So what are we going to do? So we said they're right angle triangles, so we know that this angle is going to be 90 degrees. Now, when you have a right angle triangle, it's kind of nice because there's only a few things that you can do. It's either going to be SOHCAHTOA or it's going to be Pythagoras.
Yeah.
And if we're calculating the area of a circle, we're going to need to know, or the area of a segment of a circle, we're going to need to know the angle.
We are.
So that's what's going to be coming up. Ooh, a little bit of cross-cutting, like hinting about what's going to be coming later. Ooh, what we're going to do. So first thing we're going to do is we're going to calculate angle A to O to B. Now, what sides do we know? Well, I'm glad you asked. We know 10 centimeters and 15 centimeters. Let's label up our triangle. What side is this? Shout out on the chat. O to B. Which side of the triangle is O to B? Which is it? Is it there are 3 different sides of a triangle. O to B is which side of it? Let me know, please. Please let me know.
Well done, it's the hypotenuse.
Yes, killed it. Well done.
It's
amazing.
The hypotenuse.
Really, really good job. So that's the hypotenuse. And then the angle we care about is A to O to B. So this is going to be our adjacent. And we're going to use that nice phrase, SOHCAHTOA, which means like sine, opposite, hypotenuse. You know, yeah. I'm not going to go through it. You know it. So for SOHCAHTOA, we're using cut. So it's the adjacent over the hypotenuse. So it's 10 over 15. Now, I don't have I can't do inverse causes in my head, so no. I'm just going to.
But in your exam, you just press Shift cos to get cos minus 1, and then in brackets you put 10 divided by 15.
Exactly.
And that will give you the answer in degrees.
Boom. So 48.189. So we know that angle A to O to B equals angle A to O to C. Love that because it does.
Well, because basically you've got two tangents, all right? So those tangents are going to make what we call a kite, which is completely symmetrical, all right? So those two triangles will be just the same, but just mirror images of each other.
Love
so
that.
those two angles will be the same.
Okay, so again, giving you all those theorems today. So we just double that, so we know that angle A to O to C is 96.378. So we now need to calculate the reflex angle. What's the reflex angle? Well, let me tell you. The reflex angle is this bad boy here, okay? So that reflex angle is just going to be 360 minus A to O to C, because angles in a circle add up to
360.
Oh, 360. We got it. We on it. We're doing great. What a riveting Friday evening. So we know that it's 263.622. Area of a circle. Pi r squared sounds like area to me. So that is what we're going to be using to calculate this.
So that's the area of the whole circle. Just
all of it.
Yeah. Pi times 10 squared equals.
Honey, I'm going to check that out.
Yeah, we'll get me down.
So we know the whole circle is 3.14.159. Are we done? I don't think we are. So we need to do the area of the blue region. So what we do here is we do the total area times by the fraction of the circle that we care about. So that reflex angle is what we want. That reflex angle is 263.622. We divide that by 360 times it by the area, and boom, 230.05. Remember, 2 decimal places, always double check that. And we have our area of the blue region. And well done for those who got their answers in. Really, really good.
So 1 dead pixel, you're so close to the answer. You did put 1 dp in your answer, which is fair enough. But don't forget, it says in the question, give your answer to 2 decimal places. Well done. He's done a good correction. So just make sure you don't mess that. Yeah, gong him for that.
The correction. That was amazing. Bam! Okay. Good job. Boom! Check. Done. Check. Let's go. Next. I'm so ready. I'm so pumped right now.
Right, let's move on. Let's look at another circle theorem question.
Oh my God, you can take this one. It's too much excitement for me.
He just loves circle theorems. He can't get enough.
Can't get enough. It's a lot.
So a circle with centre O has points Q, E, and R on the circle. All right.
Yeah.
Now W is a point outside the circle.
It's not in there.
It's not involved.
Circle of trust.
It's a little bit of a loner in the corner. So the lines OQ and OE are radii of the circle. The lines Q, W, and WE are tangents that have been drawn to the circle. Okay, and then some other stuff about some distances. My brain is currently going, I can't remember all of that.
Yeah.
Right? Now, in the exam, you may be given this image. You may not be. We've given it to you here. So if you haven't been given it, what you should do is just do a little sketch, all right? Yeah. Because it's impossible to remember all that information and make it make sense and picture what you can see. So just draw it out as you go by bullet point by bullet point.
Exactly.
So this is basically what we've got. And the question asks, circle and the points Q, W, E, and R are shown in the diagram. Using the information, prove that OQW equals 90 degrees. Okay. Do you know what? Proof questions, they're just an absolute nightmare.
They are a nightmare. They're hard. But so this is higher tier. It's hard questions. So we're going over the tough stuff for you guys today.
We are.
So this would, I'd say, like 7 to 9 proof questions.
Exactly.
Normally. So if you're like, that's the level we're at. Just so you all know.
So
but let's go.
As John has said, we've got right angles here. And just like the last question, we could draw a line right down the middle here to make 2 triangles, right? And that would just split this 130 degree angle in half. And because it's a right angle triangle, John has said it earlier, there's only a couple of things you can do. It's trigonometry, your SOHCAHTOA, or your Pythagoras, all right? So we can work out the length OW, so O from the middle to W, using Pythagoras and by using trigonometry.
Nice.
Right?
So like proof questions, you've got to give 2 ways of answering the question.
Exactly. So what we're doing then, by proving that it gets to the same answer, it's proving that we've got a right angle triangle here, okay? Because Pythagoras only works with right angle triangles, as does trigonometry. So if we can prove that trigonometry gives us a certain length, OW, and that Pythagoras gives us the same length for trigonometry, we prove that it must be a right angle triangle.
That is evidence.
Right? This is a really good question. This is like I reckon an 8 and a 9.
Yeah, boom.
So first we'll calculate OW using Pythagoras. All right. So we've got 12 squared plus 100, 25.73 squared is OW squared. And I don't have a calculator, so you just add them together and then square root it to find OW and find it's 28.39. To do decimal places, one dead pixel's favourite.
Yeah, love that.
And then you calculate the angle.
Yep.
That's going to be QOW to start doing it with trigonometry, right?
Yeah.
So you divide by 2, 130 divided by 2 is 65.
65.
And then you can work out using your SOHCAHTOA. Remember that we're going to use cos because we've got the two sides we've got, or the one we've got is the adjacent here. And we're trying to find the hypotenuse. So CAH, adjacent hypotenuse, all right?
Like a cough.
So if you work that out, you do 12 divided by cos of 65 to find out the hypotenuse.
Perfect.
Again, I don't have a calculator. We should have bought a calculator.
Next time, honey, it's all good.
Okay, and that will give you 28.39. What do you notice, Jono?
I think that's 2 decimal places. That's what I'm seeing.
I noticed that. What else do you notice, Jono?
So many things. So it's just sensory overload right now. They're both the same.
They're both the same. Gone that.
Crazy.
And what does that mean, Jono?
It means that the statement is true.
It is
the
true.
Prophecy is real.
It's
amazing. So that angle's 90 degrees.
Absolutely proved it.
Oh my god, I love that.
So OW is the same length using Pythagoras and trigonometry. Therefore, OQW is a right angled triangle.
Yeah, it is.
Oh yeah.
Boom. I'm loving this. This is so good. I might just sign up for the exam. I'm so ready.
Just buzzing off circles here.
So good. Oh, love that.
Okay. Well done to Genius 456 on that as well.
Yeah,
good
work. You are a genius.
You are a genius.
Done. Okay.
Should we have a look at this triangle question?
So yeah, we've done a lot of circles. People were also asking for triangles. So thanks for everyone with those requests coming in. So we're going to do a slightly hard triangle question. Do you want me to take this one, Ricardo?
Go on, Jono.
Okay. Oh, John Joe. People call me John Joe.
John Joe Shelby.
Yeah, I quite like that.
John Joe.
I love a nickname. So triangle XYZ is shown in the following diagram. Calculate what is from my answer to 2 decimal places. What? So we've got a nice triangle, and it's lovely and drawn out. It is a cool question. Thank you. And what we're gonna do.
I actually wrote this question, by the way. So thank you very much.
The brains behind the math.
Cheers, curry.
Right here. So what we do is, whenever I see a triangle and we've got to calculate what A is, I always think, okay, what do we need to know about triangles in this exam? We need to know SOHCAHTOA, Pythagoras, sine rule, cosine rule, and area of a triangle. Those are the 5 things. So it's got to be one of those. So if you're stuck, just think like, okay, what's on the spec? What do I need to know? Now, when I see 2 sides and a nice little angle in between, I like to think of area of a triangle.
You're so right, John.
So right, because that equation, it's half AB sine C. And my top tip here is to label your triangle straight away, because otherwise, honey, it gets confusing and like there's letters and numbers everywhere. So I'm going to label this right now. So I'm going to say that this is angle C, because that's the angle we got. So we can then label this side little c, because
do you remember you do? So you do big C, and then the side opposite that angle for big C is little c, and the same with big A, little a.
Perfect.
Big B is opposite little b.
Love that. Opposites attract. Paula Abdul said it, and now triangles are saying it too. It's a journey. So next we need to do A and B. Now we can just pick, like, A could be this one, A could be this one, just as long as we know one is A and one is B. So what are we going to do next? So we know that the area is 5√2 centimeters squared, which is also a little hint that you're going to be needing to use half AB sine C. They've given us the area, so we're going to be using this question. So now we form a nice little quadratic, which was also requested. You're very welcome. So 5√2 is going to equal half AB, so 3A plus 1, A plus 2 sine of 40. So we then need to simplify. So we're gonna type, I don't like fractions. Fractions make me feel anxious, and if I can get rid of anxiety, I'm gonna do it. So I'm gonna times everything by 2. So then I've got 10√2 equals 3A plus 1, which is sine, which is A, A plus 2, which is B, sine 40, which is our angle C. All slotting together nicely. I love it when a plan comes together. Ooh. So now we're going to simplify. So we're going to expand those brackets. Remember, when you do it, you need to times everything in one bracket by the one in the other bracket. So draw a cute little arrow from 3a squared to a, a cute little arrow from 3a to the 2, and then do the same for the 1, so no one feels left out. We are an all-inclusive channel here at Seneca, so no one is getting left out.
I'm just going to expand that quadratic.
Boom.
Inclusively.
Inclusive expansion. That is what we like. That is what we're about. So we know that 10 root 2 equals 3a squared plus 7a plus 2 times by that sine 40. Now, what do we do next? Simplify. Get rid of that sine 40. We don't want it no more. We are going to do 10 root 2 divided by sine 40, and then that gives us a nice little quadratic all by itself. Look at that. Look how nice that looks. This is how you want to be laying out your answers.
Nice.
Step by step. Even put the numbers in. The examiner will love it. It's a party. So, luckily, 10 root 2 divided by sine 40 is 22. And then we've got a quadratic, so 22 equals 3a squared plus 7a plus 2. Now again, like with what we did with triangles, we think about what we know about triangles. We can do the same with quadratics. When we have a quadratic, we can think about, how could we solve this? Maybe we could complete the square, maybe we could factorize, or maybe we could use the equation. And if I see like a 3 in front of the a, I'm like, honey, I don't know if I want to deal with trying to factorize that. So I'm probably going to think about quadratic equation. So we always make that one. We always make one side equal to 0, because that is when we can start to use the quadratic equation and factorize. So 0 equals 3a squared plus 7a minus 20. And then quadratic formula we get given on the front.
Not anymore.
It's changed. That's right.
It's changed. Not anymore. So you need to remember.
Remember that. Make a little flashcard with the quadratic formula in. To look at just before, and then as soon as you get in the exam, you can just write it down. So the quadratic, we then just sub in the coefficients, fancy words for numbers.
Should we remind them what the quadratic formula is?
Yes, please.
Okay,
that would
so
be great.
Minus b.
Yep.
Plus or minus.
Yep.
The square root of b squared minus 4 times a times c.
Yep.
All of that divided by 2 lots of a.
Okay,
right.
Perfect. And then A is going to, so our A is going to be 3.
Yeah.
B is going to be 7.
Yeah.
And C is going to be minus 20.
Yeah.
Awesome. So now we can just sub all of that in. So minus 7, that's the minus B, plus or minus root 7 squared minus 4 times 3 times minus 20. Watch out for the double negatives, hey? Like, that could confuse a lot of people. So minus
minus number makes it plus that number.
And then we divide by 2a.
Yeah.
So it's 2 times 3. So then we've got minus 7 plus or minus root 289 divided by 6. And then remember, there's always 2 answers because it's plus or minus. Give them both to decimal places.
And what you can do is you can just type those numbers in your calculator to work out what it actually is, all right? Exactly. So if you do it first with minus 7 plus the square root of 289 divided by 6.
Yeah.
And then do the same with minus. So minus 7 minus the square root of 289 all divided by 6.
Exactly. And also,
go on.
Also, I was just going to say, if the answer is to 2 decimal places and then you've got a quadratic, it's a hint that you need to use a quadratic formula. Don't waste time trying to factorize, because then you can't factorize to decimal places. Like, ain't nobody got time for that. So another little hint. Okay.
Thank you very much to Amax Z. We tried to be helpful, so I'm pleased you're finding it helpful. Let's move on though, John. Let's
go. Should we do some, what should we do next?
I worked hard for this.
Yeah.
What should we do next?
So hot in this room.
We've got 5 more minutes. Should we do a couple of questions?
Let's do some algebra. Yeah, we love a bit of algebra up here at Seneca.
Right, so question is, rewrite x squared minus 8x plus 3 in the format x plus a squared plus b, with a and b as integers. A classic question. I think you'll agree, John.
What is an integer? Tell me.
Integer, whole number.
Whole, I can make you whole.
Can be positive, can be negative. It doesn't matter.
It's 0.
It just needs to be a whole. It is an integer. Yeah.
Love it. Love it. Okay.
Right. So let's have a look at how we do this. So first things first, you see a quadratic. All right. So this is this x squared over here. You see this quadratic?
Yeah.
And it's saying, let's rearrange it into something. You expect, let's probably think about factorizing this or finding some way of doing it. And in this case, we're going to be looking at this. This is like what the answer is for completing the square.
Oh, I love it.
So we complete the square. So good, so good.
How do we do that?
You know you love circle theorems.
I do love circle
I think
theorems.
completing the square might be my favorite.
Love it. Oh my god, we picked the questions well today. We were organized today.
So what we do, it's really, really straightforward, although it sounds very difficult, right? So we do x. So in this first, you basically draw out a bracket, and you write x minus half of whatever this b is. Do you remember b from the quadratic formula?
Such a good tip. It's always half, isn't it?
Yeah. So it's always half of that. So it's x, in this case, you've got minus 8, so half of that is minus 4. Okay. So you've got x minus 4, and you just square that, right? Okay. And then you basically work out what x minus 4 times x minus 4 is. So that would be x squared, thank you, John. It's okay. Minus 8x plus 16. Yeah. Now you notice that x squared minus 8x, x squared minus 8x. Matchy.
Oh my god, samey.
But plus 16, okay, and plus 3, not matchy.
No.
So we're going to have to do something to make the plus 16 change into a plus 3.
Yeah, we are.
What can you do for that, John?
I think we're going to have to add some kind of number.
Maybe even take away.
Oh, take away. I meant like...
I know what you meant, but I was just being a bit pinicky.
That's what we want. You've got to be specific in that exam.
So to change this from x squared minus 8x plus 16 to this, we're going to need to take away 13.
Yeah, we are. Okay? That's so true.
So we can actually say that this is the same as just this bit, x minus 4 all squared, take away 13. And it's as simple as that. And then the question asks, don't forget, what is a and b as an integer? Are they integers now, John?
Yes, they are. They are whole numbers.
You can take me whole again.
You can take me whole number again.
Okay, so a is here, it's minus 4.
Love that.
Okay, and b is minus 13. Don't forget it, just because it says 13 here doesn't mean it's like a plus 13. Look at the sign as well.
Yeah, exactly.
Jono, go me. Actually, don't go me. One dead pixel.
One dead 4D pixel is the full name, I believe. It's a lot to take in. I don't know how to say it.
I think it's dead like with a 4. An A and a 4.
Oh my god!
One dead pixel.
I'm so.
If you can clarify for that for us, one dead pixel, that'd be much appreciated.
I'm so old. You're so right. 1D4 pixel is what I was gonna say. Well done. You got the answer correct. Ooh, that was loud. People are gonna be angry.
Right. I think we got a bit more time. We're gonna squeeze in a simultaneous question for the good people.
For the good people who kept turning off. Sorry, did I just push your hand?
No, you didn't.
Oh, God. I thought I just smashed Richard's hand, but I didn't. You guys spending your Friday night going over some maths? So impressed.
Right, solve this pair of simultaneous linear equations. Do you want to take this away, John?
Yeah, let's do it. I love simultaneous equations. I don't want to enable series. Sorry, pun. So there are so many ways to solve simultaneous equations. But in this case, we're going to go over the approach where you make the x and the y values in the two equations equal. So what are we doing? We are going to times the bottom equation by 2, because that gives us 18. Okay?
Well, it matches up the number of x's.
Yeah,
in the two equations.
Perfect. That's right.
Yeah. So we got 4x on the top equation, and then we got, by timesing everything by 2, we got 4x on the bottom.
Love that. So now we can just add. It also gives us plus 2y, and we've got minus 2y, and we have a plus 2y. So if we add those equations together, what's going to happen to those y's?
It's going to completely eliminate them. Eliminated.
They are going to cancel. So we add those two cute little equations together, and that gives us 8x equals 26. Okay, so just to clarify what we've done, we've seen we've got 4x minus 2y equals 8, and 2x plus y equals 9. So we need to make the coefficients, the fancy word for the number in front of the x or y, we need to make them the same in two equations. So
correct.
You can choose the x or the y. We went for the y's because then we can add the equation. So we times the bottom one by 2, so we've got 4x plus 2y. And then we do 2y, we add them together, and that gives us 8x equals 26. What do we do next? We just divide by 8, nice, 3.25, and well done, the one. You got that answer, and to clarify, it is one dead pixel.
Nice, thanks. One dead pixel.
Thanks.
So then the next thing you do, once you've got x, you're not quite done yet, you need to find out what y is, okay?
Yeah.
So you substitute in that x equals 3.25, in for anywhere you see x into one of the equations. So we do 4 times 3.25 minus 2y equals 8, and that's from the top equation up here, right?
Stunning.
And then we literally times 3.25 by 4 and solve what the equation is for y. I'm not going to do that now in full, but basically you can just solve that. If you're not sure how to do that, go and look at our courses on how to solve linear equations, because that's that last bit's the easy bit.
It's the easy bit, and we would go through it, but we've only got half an hour, so we have to dash off, sadly.
So well done to the one, gong him,
boom,
or her. Sorry,
exactly. We don't want to assume anyone's gender or they. Exactly.
Whoever they are.
Whoever they are. Boom. Let us know your pronoun of choice, and we will uphold your desire.
Answer to Robin. So paper 3 is not necessarily the hardest because the content's the same over the whole all 3 papers. Okay, the only difference is that the second 2 papers are calculated papers, and the first one is a non-calculated paper. Amazing, guys! This has been so much fun. We've had a great time.
Thank you so much for joining on a Friday. It's a Friday afternoon, evening. And you had exams today, and you're coming to this live stream. Thank you. Watch it again over the weekend to clarify it. If it's been useful, let us know, and we'll do some more. Also, is anyone doing chemistry next week? We just released a really cool video going through all of the organic chemistry you'll need to know. It's a riot. It's a riot. Someone was already shouting it out in the comments, but I'll share the link if anyone else wants to check it out. Good luck with your exams.
Yeah, really good luck. You're so close to being done. So close. Okay, the maths is about to be out of the way.
Exactly. And then it's going to be summer. Damn, you're going to have your own fan. You're going to be lying in the sun.
Last thing to say, guys, is don't forget we do these every day. So if you've got an exam the next day, then come up and see us for our live streams. We do them for all subjects, not just like maths, science and stuff. We do them for everything.
Yeah.
The other thing is we want you guys to have a place where you can go and chat about all of this. Okay.
Yeah.
So we have set up a rabbit room for you to go and actually have a look at what's going on. John is going to put the link in the chat right now.
I will.
And what you can do on there, we'll come in initially and we'll just show you how it works.
Yeah.
But basically, we're going to give you an opportunity to just go together as a group, just continue your revision and whatever you want by being able to go through some different bits on the live chat. So join us by clicking that link. For Rabbit.
Yeah. It's just in the
chat.
the
link?
Yeah.
Oh yeah, that is
the link.
Nice, cool. Nice one. So click on that, and we'll be there in a minute to get you started, and then you guys can continue your Friday evening of revision.
Friday night math party. Love it. Friends who study together stay together. No, I don't know. I just made that up on the fly, honey. I'm ready. Let's go. Okay, catch you in Rabbit. Thank you so much. Good luck for your exams. Also, we do night before podcasts for the different exams, so check those out too. Listen to them on the bus on the way to the exam. Listen to them to go to sleep. It's great. It's so fun.
I'll see you on Rabbit in about 10 seconds.
Bye.
Bye.